All right, ladies and gentlemen, that's the theme song of the day. If any of you know what that's from, I have gained deep and profound respect for you because I think me and 4 people from Wales are the only people that have ever watched that television show. Welcome back. We're going into a new chapter now. Now, I recently discovered that the book that I have at home that I've been working out of is slightly different chapter-wise from the book that you're learning from. So right now, I'm teaching from chapter 22. The title of the chapter is Chemistry at the Alpha Carbon to a Carbonyl. So this is enol and enolate chemistry. This is a pretty dense chapter. And frankly, this is where a lot of people just decide, I'm done, hang up their hats, and go home. Please don't do that because we've got to get through this section and another section toward the end about aromatic chemistry. So don't give up quite yet. What we are talking about, and this is going to be a general overview of the entire subject to start with, then in future videos we'll go in and get into some of the more specific detail. What we're starting to talk about now is a very old system of nomenclature. So, I think I put way too many carbons on there, so I'm going to make an idiot out of myself. But let's say we have a carbonyl right here. What is that? 2-nonenone? All right. So what we have is we have old ways of naming positions. Not necessarily the specific carbons or what's there, but the positions. And those are positions with respect to something of interest. And in our case here, that something of interest is this carbonyl. So what we have got to be able to do is identify positions with respect to that carbonyl, and we do that using the Greek alphabet. So the carbons immediately adjacent to the carbonyl are called alpha. Those are called alpha carbons. And the protons on those carbons are called alpha protons. Now, 2 carbons away from the site of interest would be beta. So this would be a beta position here and here. Notice that they're both called alpha and they're both called beta, even though there are 2 of them with respect to that carbonyl. Now, after that, we have alpha, beta. I've always struggled to do gamma, so we're going to call that gamma. Delta, alpha, beta, gamma, delta. Epsilon, and then this is where my Greek falls apart. So let's just pretend this one doesn't exist. So what we are talking about for this next chapter is chemistry that happens at the alpha position. Or specifically in this case, chemistry that's taking place on the carbons adjacent to a carbonyl. Now, early on when we started talking about these, we established the keto-enol tautomerism. And one of the things that we talked about was the fact that these 2 molecules are tautomers of each other. Now, these are isomers that differ by a proton and a pi bond. To me, it sounds like they were really searching to figure out what to name these things. But there is a tautomerism between the ketone and the enol. Now, the tautomerism generally greatly favors the ketone. There are a few exceptions to this, and we'll talk about those when we get there. So this is the neutral version. However, there is one that is caused by bases, and there is an entire discussion we get to have about the bases of choice to see this sort of chemistry. So let's go ahead and look at something like this. That's not a B, excuse me. That would be an H there. And let's bring in a base with its pair of electrons to pull that proton off, and the electrons stay behind on that carbon. Was there a big specific reason I switched colors at that point? Probably not. I just felt like doing it. So now we are at this anion. Now this anion has a resonance form where this occurs. The anion forms a pi bond between the two carbons, and the carbonyl pi bond breaks, and the electrons take up their new home up here on the negative charge. Excuse me. Let me try saying that so it doesn't suck. The electrons take up residence on the oxygen and give you a negative charge. This is called an enolate. Notice the ATE at the end, similar to carboxylate that we see when we take the proton off of a carboxylic acid. Now, in the enolate system, this is where the book and I are going to have a pretty severe disagreement. What you need to know about the enolate, and we will talk about the kind of bases, how they form, what the ratio is, etc., is if you look at the enol and the enolate, and remember these are resonance forms of each other, then you can draw a resonance hybrid. And the resonance hybrid would look like this, where all the sigma bonds are where they need to be. You get dashed lines everywhere you have pi bond density. You get a partial negative at the oxygen and a partial negative at that carbon. The point of this, and what makes the chemistry so potentially interesting, is the fact that with both this carbon and this one, because they both exist at the same time, what you've got now is a nucleophilic carbon. In fact, a nucleophilic carbon that is reasonably stable and is not as likely to fall apart on you as, say, a Grignard or an alkylithium would be. All right? So, you get the same sort of thing with the enol. Now, I want to remind y'all here that this is a base-mediated pathway. If you go with an acid-mediated pathway, you get something that looks like this. Like you've seen 1,000 times before, the carbonyl oxygen grabs the proton off of the hydronium, fast and reversible step, and you are here. Now, the difference is, instead of a nucleophilic attack, now we would deprotonate this carbon alpha to the carbonyl. Now, notice what happens when we pull that proton off. One, the OH2, the water, grabs the proton. The electrons form a new pi bond between the carbon, and the carbon-oxygen pi bond breaks. And you generate this enol. Now, we have established that enols don't exist for very long. They promptly tautomerize back to the ketone, and that is absolutely right. But what I want to point out to you here is, once again, you have generated a nucleophilic carbon right there. So that gets into about half of what this chapter is about, which is nucleophilic attack from the enol or the enolate carbon. The second half has to do with conjugate additions, and we'll talk about that when we get there. So really, this video is all about prepping you for what's coming up. This is a weird chapter. It's sort of weird with its content, and I don't want you to get steamrolled here. So I heartily encourage, nay, I beg you, to please take a look at this stuff ahead of time. Take a look at it, see what works, go through the chapter. It'll help you a lot as we go forward. I anticipate there being 5, maybe 6 videos out of this. Who knows? It could turn into 10. I do love the sound of my own voice, and who wouldn't? It's deep, it's rich, it's like caramel. At any rate, I want you to be aware of what's coming up and where we are going. So, everybody, enjoy your time. I will talk to you soon.